When an object undergoes projectile motion, it has motion in both the x and y directions. Also, those directions of motion are independent of each other. The following notes will go more into detail about this phenomenon. We use kinematic equations to describe the motion of a ball in a certain direction. Given that motion exists in both x and y directions, and those motions are independent of each other, we need two sets of kinematic equations, one for each direction. We can replace the vector quantities in the equations with their directional components to do this, thus yielding the equations on screen. Time is a scalar quantity, meaning that it is the same for both directions. On the right is a diagram for the directions we will consider as positive and negative for each component. We know that there is no acceleration in the x direction, since there are no forces acting in that direction. This comes from Newton's second law, which is covered in a different topic. Thus, the x direction equations ultimately imply that velocity remains constant when the ball is traveling in this direction. The acceleration in the y direction is the acceleration due to the gravitational force. Its value is minus 9.81 meters per second squared. The value is negative because gravitational force acts towards Earth's center. We can use the constant g to represent this value. Thus, we get the y direction equations on the screen when g is substituted for a sub y. Finally, remember to use trigonometry when resolving the vector quantities into their components. As a reminder, we take the cosine of the angle the object is traveling in relative to the horizontal for the x component, and the sine of that angle for the y component.
Go. Okay, I saw the Okay, yep.
The purpose of this demo was to show how no matter what path the ball takes in projectile motion, motion in the x direction is independent of motion in the y direction, with the times being the same. We saw a ball experiencing free fall and the same one experiencing projectile motion. Both took approximately the same amount of time to travel their y displacements according to the videos. The first part had visible x displacement, while the second part had an x displacement of 0 meters. This goes to show how time remains constant among motion in the components and how motion in the components are independent of each other.